We're back and we're looking at line graphs here, and I'm going to say the same thing. We're under time constraints here. Some people might want you to get the ruler out and make everything perfect and put it on a graph paper or something. Okay. If we had the luxury of time, we could jump on the computer and put these data points into Excel and do a nice graph. But what I'm trying to get you to understand is that we can draw a quick sketch and we can tell the story quite easy. So the key things I want you to remember is that you need to set it up so the person looking at the graph that you've drawn can see all the information. They don't have to guess what's on each axis. So you need to write down what the description is for each axis and also include the units because that's important, okay? And do your best to just roughly put even spacings between them. We're not going to be millimeter perfect here, and you can see what I'm doing here. I'll do some more on the light board here, but I'm just thinking about a basic graph. We've got age versus height, and you don't start off at 0 centimeters tall when you're born. So that starting point is over here somewhere, and as you grow, we take various measurements here and we expect something to be happening like this, where we've got the data points and we draw a line through them. If the camera's picking this up, it might be better on the light board, but that's my sketch. It is a sketch, remember? I've done the best. I've written down what I'm measuring on this axis. I'm putting the units up there. I've got some age. I've got age and years here, so we get a sense of what's going on. And we can quickly make a decision about what's going on and what we expect to have happen. We kind of expect that if everything's going well, that a person, as they age, is getting taller. And then perhaps in their 20s, that settles down a little bit. And perhaps if we continue with the data, till these people were 60, 70 or 80 years old, we'd expect maybe a little bit of the sort of decrease in their height as well. So what would have appeared a straight line initially might plateau, and then we might see a slight decline as well. So it's that sense of what is happening, and the graph is there to help you summarize the data and help you tell that particular story. All right. Okay, in this video we're doing some work on line graphs. I've just drawn out a set of axes here, and look very carefully about what is written on the axis here. So we call these the labels, and that helps us determine what's happening with this line here. So those labels could be time, and this could be distance on this axis here. Always look for the units too, because it might be a BH for an hour, and it might be, say, kilometers there, and we might be plotting out how far a person walks. And so that might be 2 hours, that might be the next hour, and so on. That might be 3.5, and this might be 4. Who knows? That's a general thing. And then when with our eyes we can read off onto the other axis what the distance is at different points. Okay, so that's a general idea of what we're doing when we're drawing a line graph. We're sort of representing all that data and telling a story about what happened. So let's do that story. Let's actually do this. We've got a hiker who's walking, let's say 5 kilometers in the first hour. Okay, 2 kilometers in the second hour, and then they're going to have a rest for an hour, and then they're going to walk 3 kilometers so that was the third, so this would have to be the 4th hour. Okay, so when you get all that data, you're asked to plot that on a line graph. And so first thing you do is you draw 2 lines at right angles to each other. Then you need to label your axes. So time is always down on the horizontal axis, and we're measuring time in hours, so H for hours, and we're up here, we've got distance in kilometers. So we've done that. So what we're talking about here is someone's movement over 4 hours. So we might come down here and do our best to space these things out and get a rough idea of when we add up those numbers, we're kind of looking at just 10 kilometers. So why don't we do this, go into the middle and put 5 there, go up somewhere near the top and put 10 kilometers up on the axis up there. And now we can start plotting things out. So in the first hour, we walk 5 kilometers. So I might put a little mark there to mark in that point. And in the second hour, we walk 2 kilometers. So I'm thinking that might be, let's call that 7 there. And we're coming across and just rough sketch, right? We're trying to line these things up. And then we rested for an hour, so we didn't actually go anywhere. So our distance hasn't changed. And then in the 4th hour, we walked, 3 kilometers. So we're already at 7, so that's going to take us up to 10. And I'm just kind of doing this kind of thing now, going across and putting a little mark there. Okay, so we started down here at time 0, and we walked 5 kilometers in the first hour. Then we walked another 2, then we had a rest, and then we walked another 3 kilometers. And what I want you to notice is that, and you can see this from the story, the amount of distance covered in each hour is slightly different. Okay, so the slope of the line, or the steepness of the line, tells us something about the speed that this person was walking. So just think back to the first hour, they covered 5 kilometers in the first hour. So this line here, and it's probably hard to see now, but this line is the steepest of the line. We've covered the big largest distance in the in that hour. So the graph now tells a story, and that's the kind of thing that I want to get across to you. And when you learn to read these graphs, what you're doing is telling a story. So I'm going to start with no information, and I'm just going to label these axes with time and temperature, temp, in degrees Celsius. Okay, and we might do this right here. This is 12 a.m., 12 p.m., so noon or midday, and then midnight again at 12 a.m. So I'm thinking of something along, telling a story now along the lines of like here in Australia, our houses sometimes are like wooden wooden boxes, and during the day, what's going to happen? So when the sun rises, and we might draw a picture of the sun there, and when the sun sets, let's start to think about what happens with our temperatures. So in our houses, what tends to happen is that the house cools down at night and then reaches a minimum temperature. Sun comes out, starts to rise, the house heats up and stays warm until the sun goes down, and then it starts to drop again, and we're on this sort of cycle, and we can tell these stories using line graphs. So that's the kind of thing that I want you to... There's a lot of questions about temperature and houses and stuff like that in the work that we're doing. So start thinking what happens in your house, and that'll help you understand these types of questions a little bit better. And of course, there's a few questions about air conditioning. If we're at home and we want to maintain a certain temperature in the house, we can turn on the air conditioning there. And what we do if we're trying to maintain the temperature at 23 degrees, well, we're going to end up with that blue line, which is creating that stable environment. Okay? Thank you.